Ionic mechanisms underlie the action potential. Alan Hodgkin and Andrew Huxley took advantage of the giant axon of the squid from a neuron involved in the animal's emergency escape behavior. They established that the action potential is created by the movement of sodium ions into the cell through channels that open up the membrane. Nernst and Goldman equations show that at its peak, the action potential approaches the equilibrium potential for the sodium ion, Na+, and that peak is plus 40 millivolts. The voltage-gated ion channel, or the voltage-gated sodium ion channel, is just like other ion channels. It has a tubular membrane spanning protein, and its sodium selective pore is ordinarily closed. When the membrane is depolarized to threshold levels, the channel's shape changes, opening the pore, allowing the sodium ions through. Refractory is referring to transiently inactivated or exhausted axonal membrane. Absolute refractory period is a brief period of complete insensitivity to stimuli. Relative refractory phase is a period of reduced sensitivity during which only strong stimulation produces an action potential. Axon hillock refers to a cone-shaped area from which the axon originates out of the cell body, functionally the integration zone of the neuron. Voltage clamping and patch clamping. Voltage clamping is the use of electrodes to inject a current into an axon or neuron to keep the membrane potential at a set value. The apparatus measures how much current must be injected to counteract any ion channel openings. Patch clamping is the use of voltage clamping to monitor current flow across a tiny patch of membrane taken from a neuron. Action potentials are actively propagated along the axon. Conduction velocity is the speed at which an action potential is propagated along the length of an axon or section of the peripheral nerve. The node of Ranvier is a gap between successive segments of the myelin sheath where the axon membrane is exposed. Saltatory conduction is the form of conduction that is characteristic of myelinated axons, in which the action potential jumps from one node of Ranvier to the next. Synapses cause graded local changes in the postsynaptic membrane potential. Neurotransmitters are also called synaptic transmitters, chemical transmitters, or just transmitters. Neurotransmitters are the chemical released from the presynaptic axon terminal that serves as the basis of communication between neurons. Changing the channel. Channelopathies are a genetic abnormality of ion channels causing a variety of symptoms. Tetrodotoxin, or TTX, is a toxin from pufferfish ovaries that blocks the voltage-gated sodium channel, preventing the action potential conduction. Saxitoxin, or STX, is an animal toxin that blocks sodium channels when applied to the outer surface of the cell membrane. And batracatoxin is a toxin secreted by poison arrow frogs that selectively interferes with sodium channels. Synapses can be excitatory or inhibitory. Postsynaptic potentials is a local potential that is initiated by stimulation at a synapse, and it can vary in amplitude and spread passively across the cell membrane, decreasing in strength with time and distance. Excitatory postsynaptic potential, or ESPS, is a depolarizing potential in the postsynaptic neuron that is caused by excitatory conditions. ESPSs increase or ESPs. EPSPs. Okay, that's what it is. EPSPs increase the probability that the postsynaptic neuron will fire an action potential. Synaptic delay is the brief delay between the arrival of an action potential at the axon terminal and the creation of a postsynaptic potential. Inhibitory postsynaptic potential, or IPSP, is a hyperpolarizing potential in the postsynaptic neuron that is caused by inhibitory conditions. IPSPs decrease the probability that the postsynaptic neuron will fire an action potential. The chloride ions is a chlorine atom that carries a negative charge because it has gained one electron. And that is the conclusion of the Chapter 3 summary, Segment 2, from pages 68 to 74.